Hey guys, my name is Ivo and I'm from MyTestedASP.net. In my previous video I talked about how to improve expression compilation, and I got excited and decided to record another one in which I'm going to test how fast the fast expression compiler actually is, because in the previous video we didn't have functions with closures and with constants outside of the function scope, so I got curious about how fast actually it will be the compilation when I have such expressions with constants and variables outside of the expression scope. So consider this video more of a playground, more of a testing the waters here, and not like the regular videos about lecturing and teaching stuff. So if you find the topic interesting, bear with me, and we're going to test how fast the compiler actually is. Okay, so I'm going to test two things. First, I want to extract an expression which has constant value from a variable. So I would like to have a class cat with some method say meow, for example, which receives string text and returns meow plus that text. Okay, so my expression will be expression from cat, which returns string, and that will be cat goes to say meow with some test, like this. But I'm going to use that from a variable, because you may already know, but variables are harder to extract from expression trees. If you're not familiar with expression trees, or if you think that this topic may be difficult for you, I have a video about expression trees. It's called Expression Trees Are Not Scary, and it's an intro to the topic, so you can watch it. Okay, so then I'm going to extract 10,000 times, or 1,000 for now, and I'm going to use a stopwatch. Good. After my test, I'm going to print stopwatch elapsed, extracting with normal expression. Okay, and now I want to extract the body of the expression.body as method call expression. Then I would like to extract the variable, which is the first argument, is body.arguments 0, and then I would like to extract it by using by creating a function to return that variable. So first I'm going to convert the argument to a expression and convert. I'm going to convert the argument to type of object. This will essentially create the following. And then I'm going to create a lambda which will return the object from that converted expression. Then I'm going to compile it, func equal lambda.compile, and I'm going to print the results. No, I'm not going to print the results. I'm going to save it in a list. I'm going to print the count after I measure. The idea here is that the C# compiler sometimes is clever and is optimizing code that is not used, and I'm currently showing that I want to use the function in this list so that the measurement will be a little bit better. Okay, that should be working. Let's see what's going on in the list. I have a test. Okay, that's great. Cool, that's the first way of extracting. It's by using the func of object way. Let's do a second test. Which will allow me to use the compile fast. Let's install that fast expression compiler. If you're not familiar with fast expression compiler, in my previous videos I was explaining about it, so you can watch my previous video. I'm going to test with the light expression too, so now I'm going to use compile fast. Okay, so there's quite an improvement actually with extracting with fast compiled expression. So I have quite an improvement, 200% improvement in using the compile fast. Let's see how fast it will be by using the reflection way to extract the variable, which is essentially a little bit strange, but I'm going to extracting with reflection. So I would have the argument, and I'm not going to the argument here var argument constant is argument dot let me check whether that's working fine. No, it's not. It's member access for expression. Great, it's member expression. So argument member. If you're not familiar with what I'm doing here, let me know in the comments, and I will create a separate video explaining how to extract variables without compiling the expression. Currently I'm doing just that. I'm not compiling the expression. I'm going to extract the variable from the closure class. Closure class is argument member dot expression as constant expression, and closure class value is closure class value. Essentially what I'm trying to do here is each expression captures its closure variables in a compiled generated class. And essentially I'm getting, here it is, here is the class. It's called C underscore display class 0 underscore 0, and I'm trying to extract that variable from the class. That's what I'm doing here. So I'm essentially using the using reflection to extract the generated class. And I can even improve that by compiling another expression which essentially gets the class from gets the property from that class, and it should be even more faster. But I should check how Entity Framework does it. They probably do it in the fastest way possible. I will check that, and if it's something interesting, I will create another video for it. Okay, so closure class value, argument member get as field info, and var value is field info get value from the closure class, and list dot add value as string. Let's see whether that works. It should be working, but I may have made a mistake, and it's fine. Okay. Again, if you didn't got that and you think it's strange, let me know, and I'm going to create a video about extracting variables like this one from expressions, because as you can see, it's not straightforward. Okay, let's see whether the expression way is, the reflection way is faster, and apparently it's way faster. And if we decide to, let me see whether the closure will be the same. Closure is display class, the closure is display class, the same closure here in this case, because I'm using the same expression tree, right? So essentially, if I use the property helper to extract that, I may even improve it even more. So I'm going to copy now the property helper to test that. I haven't tested it in my life, so it's a bit interesting. Okay, so let's create the class property helper here, and let's use it to see whether it will be even faster. Nope. Created something stupid. Okay, I would need select. I would need the expression, and I would need the compile fast from. Cool, let's test extracting with reflection and compiled delegates. So I'm going to need, this is field info. I have to get fields. I have to check whether it will work. Trying to make it work for both properties and so this should extract the fields too. We should see whether the field is public, but I believe it's public. So what I need here is to get the value. So I will need to say var field equals property helper get properties. It should be let me be correct here. Member helper. It should be called member helper. And that should come from the cache. So cache.getOrder type equals this, and return that. Okay. So working from the cache, say closure class value. Get type, obviously, and to get the value itself is that should be the first member getter of closure class value. That was extracting with reflection and compiled delegates. Let me see how this works. Oh, it's very slow. Is it cached? It should be cached. Let's see how many times this runs. One, and only one. And as we can see, it's faster Actually, it's faster than the compiled expression options, but it's not faster than the reflection itself. Maybe the reflection is caching here something, because it's quite fast. So the best way to do it currently should be by using the reflection way. Okay, so extracting constants, it should be done with reflection, not constant variables, because either the compile fast and the normal expressions are not working fast enough. So extract with reflection. That's the best way to do it. And now let's test the expression builder when we need to build a constant from when we need to build closure. So I'm going to say first slow expression, some class which will have build slow expression. So I'm going to create the same thing, a closure, but I'm going to build the expression by myself. So I'm going to create this expression. I'll need expression dot parameter, which is type of cat. It will be named cat. The body should be expression.call. I will say the instance is the parameter, and the method is type of cat.get method name of cat dot say meow, and there should be expression constant which has type of string, and the value is, actually I need to provide only the value test like this. Okay, and lambda equals expression dot lambda func of cat returning string. The body and the parameters are here. Then I'm going to compile that, and I'm going to return the function results like this. So I'm going to test with slow expression builder. Slow expression is new slow expression class. Slow expression, build slow expression, list.add value. Building with slow expression. Okay, then I will create a class which will use the slow expression, but will compile fast. Slow expression with fast compile. Essentially this, but I'm going to use compile fast here. Slow expression with fast compile. It's faster. It's a little bit faster. Building with slow expression and fast compile. And now I'm going to check. Using fast expression and fast compile. But first, I would like to thank my sponsors. As you may already know, I'm creating open source libraries, and I will be extremely thankful if you decide to support me or my channel. These libraries are for testing ASP.NET Core web applications in a fluent and strongly typed manner, and I'm doing that in my free time. So if you want to support this channel or my projects, you may leave a star or share it with your friends, or you can become a backer or sponsor on Patreon and Open Collective. Some people already did, and I'm extremely thankful for them. Some companies are also supporting me. If your company needs more exposure, let me know and I will provide any instructions. So my sponsors are Softony, Smart IT, and Noble Heart. Thank you guys, you truly rock, and pretty much that's it. Let's continue with our code. I'm going to use build fast expression, and I'm going to use the fast expression compiler light expression here, like this. So this expression is essentially should be faster, and I'm going to run that. Fast expression, build fast expression, building with fast expression. And this should be the fastest way, but apparently it's not. Turns out, let me make more bigger tests and let's see what will happen. So with a huge test, we see that for extracting values, the fastest way is to extract variables with reflection from the expression tree. I will check Entity Framework for that because I'm interested in how they do it, because there it's crucial for the performance part. And when we are building expressions, apparently building with fast compile and with fast expression is the best option, but if you want to have type safety, fast compile is better. Okay, the last thing I would like to test here is whether this member helper will be faster if we pre-warm the compilation of the delegates. So I'm going to remove that and body code, code, code. Just as a simple test. Even then, extracting with reflection is faster. So apparently there is something going on here, some sort of, maybe the COR is optimized for this kind of operations, or the reflection itself is optimized for this kind of reflection, because in one of my previous videos we saw that when we're using properties, it's faster to use the property helper, but here it is not. So I'm going to check Entity Framework how they do it, and if it's something interesting or more interesting than what I have already showed here, I'm going to make a video about it. Okay guys, that was it. That was the playground I tried to do. I tried to see which expression version is faster and how to do it if you want to use expression trees in your code. Great, and thank you for being with me. If you want similar videos, let me know. Hit the thumbs up button below. If you have a suggestion for a future topic, leave it in the comments. And again, if you want to support this channel or my projects, you can do it on Patreon or Open Collective. Thank you guys, and have fun.